Hello everyone. Hello everyone. Today we are going to discuss about fraud job detection model. The main objective of this project is going to be we are going to get we are going to use the data that we have gotten from our data source, that is from Kaggle. So from Kaggle we have gotten this data, and this data set has all the data regarding a job posting, like location, salary, profile of a company, what are the benefits, what is the department, and what is the job description, then company description. This data set has all the data like that, and most of this data is in text format. So to handle the data that is in text format, we need to perform natural language processing or sequential data processing. Along with that, we also have categorical data as well. So we are going to use that, like we are just going to perform basic encoding on that, and we will use those meta features along with this text vectors that we get from natural language processing, and we are going to build a model that is going to predict if the given job profile or if the given job posting is fake or not. Now let's get into the model building part. So here we are importing all the libraries. All the important libraries have been imported here. Then next, we are loading the dataset using pandas library. Next, we are dropping job ID column because identity columns are not at all useful in machine learning. Then we are checking the info. This is going to give us like the number of columns and what is the data type of that column and how much RAM it is using. It will give all of those things. Then we are looking at the names of all the columns. Next, here we are checking at the missing values. We are going to get the number of missing values in each column. Then we are creating missing value signals. So here what it is going to do is it is going to check if the location is null or not. If it is null, if there is location, then it is going to give the output as 1. If there is no location, then it is going to give the output as 0. Because fraud jobs often hide location and company details. So if these things are missing, then that will also act as a signal indicator for our model. We did the same with company profile, benefits, and all. Then next, we are cleaning the text from here. The first thing that we are doing is we are loading our stop words. Stop words are some of the mostly commonly used words in English, like the words like an, the, are. So these things don't hold any individual meaning by themselves unless they are paired with other words. They won't have any importance, or their vectors won't have any importance in machine learning. So we need to remove those words. That's why we call them stop words. Next, here you can see df of text is equals to title, description, and requirement. So these three columns are entirely filled with multi-line texts. So we have combined all of them into a single text column. And now we are performing text cleaning. In the text cleaning, what we are doing is first we are converting everything into lowercase to normalize the case. Then we are removing all the links. Then in the next line, we are removing numbers, punctuations, symbols, all the unnecessary things. Then we are removing the spaces. Next, what we are doing is we are performing tokenization. Here what we are doing is we are splitting the sentences into multiple words, and then we are checking if they are in stop words or not. If they are in stop words, then we are not using them. If they aren't in stop words, then we are performing lemmatization and we are adding them. Here we have applied the clean text to our text. Then we are dropping the columns salary range, company profile, location, benefits, and texts. Now we are splitting our features from our data set. We are splitting our target variable, that is fraudulent. Fraudulent is our target variable. So we are assigning y variable to it. And apart from fraudulent, all the other columns are assigned to x variable. Why do we need to do that? Because in the next upcoming steps, we will be splitting them and we'll be calling them separately. So in order to make things easier, we are splitting the data here. Next comes train test split. See, train test split is performed because if you train your model on the 100% of your data, then how will you check how well is your model performing? So to check for model performance, we'll keep a little bit of data aside. That data is testing data, and the process of splitting the data to use for training and testing is train test split. And here you see test size is equals to 0.2. This is signifying that data that is being kept aside is 20%. That means you are keeping 20% of data aside for testing. Then comes TF-IDF. TF-IDF vectorization is, this is how you are converting your text data into numbers. So you'll have vector numbers like 0, 1, 1, 0, 0, 2, 3, 4, 4, 4, 6. In this format, you will have a list output. The process of that conversion is vectorization, and each method of vectorization will have a different process. And TF-IDF method is very widely regarded to be successful, and it is also a very good method and quick method as well. So we are using TF-IDF here, and using TF-IDF we have converted everything. Then comes encoding. So here we are using one-hot encoding. One-hot encoding is very useful in binary encoding process, that is yes or no, male or female, present or absent. In these formats, if you have the data, then one-hot encoding is very useful. Then next what we are doing is we are using these meta columns, that is commuting, does it has company logo or not, is the salary provided or not. These are all the meta columns or good to have columns. So we are also bringing all of them and we are combining all of these columns using H stack, that is horizontal stack. All of them are, all these sparse matrices are stacked horizontally on top of each other. Then next we are coming to model building. Here we are checking, here we are trying to build with all the possible models that we want. And we are using class weight balanced because rear classes should get more weight. Rear classes in the sense, if you look at your fraudulent column, in that each category will have its own count. That means fraudulent will be, let's say out of 10,000, fraudulent will be 8,000, then non-fraudulent will be 2,000. That means non-fraudulent is a minority class here. Minority class will get more weightage when you use balanced. So here you are trying to build on various models, trying to build with various models. Now comes in threshold tuning function. See, here we have a huge problem with the class imbalance. So what happens is, in every classification, any model, any machine learning model that you take, it will not give you classes like 0, 1. Instead, it will give you probabilities, that is 0.97, 0.34. Now what we do is we write a threshold function for each class. That means 0 to 0.5. Probability is for class 0. 0.512. 1 is the class for class 1. I mean is the probability for class 1. We write a threshold function like this. Here we have 0.5. See, this threshold value 0.5 will be default in every case, but we have heavy class imbalance here. So we need to also change the threshold values. So to check which one is the best threshold value, we have taken all the possible values, all the random values between 0.1 to 0.7, and we have built models and we've checked metrics. If the metrics are better at any threshold value, if it is best, then those metrics are taken and that threshold value is saved. That is what is happening here. So this is the entire process of the model building. Now, once we have gotten our threshold value, next what we are doing is using the best threshold value, we are training our models and we are trying to perform the predictions here. You see, train probability greater than equals to best threshold. That's it. Based on that, you are going to get the outputs. This is how you are performing the multiple models to check which one is working good. Then, once the model building is completed, we are also performing something called cross validation. So what does cross validation is? I told you, right, in the train test split, what we are doing, we are keeping 20% of data separately for testing. So now that means that 20% of data's patterns are lost. But instead of that, what it will do is it will create folds in the data. That means based on the cross validation, let's say you are using 5-fold cross validation. In such case, it will take your 100% of the data. It will create 5 divisions like this. 1, 2, 3, 4, 5. It will create 5 divisions like this. It will keep this one aside for testing. It will train on this, test with this data. Then again, one more. 1, 2, 3, 4, 5. Now it will keep this one aside. Then next time this one, next time this one, next time this one, next time this one. In that case, your model will be tested as well, trained as well, and also it will take in all the patterns that are there inside your data. That is what cross validation is doing there. Then we are packing our model using joblib.dump code. Joblib.dump and joblib.load is how you load your model. Here you can see This is your model packaging. That is the model that you are using, which is our logistic regression, and the vectorization is TF-IDF, the encoding, and what is the best threshold value. Using all of this, we are creating our final model. So this is the process of building the model for fraud job detection. Then how do you deploy this? To deploy this, we must need to, like, basically we are using Streamlit, but you can use Flask as well. It's all up to personal preferences. But Streamlit is a very staple among data science community. So here also Streamlit is being used. Now here we are loading the models. Then here we are writing categorical columns and meta columns. Here we are just defining the columns. Okay. Then we are writing all the text cleaning function that we have used in the training. Same as training, nothing different. You just copy and paste the code here, it will be done. Then here you are taking all the inputs from the user. Say title, description, requirements, all of the inputs are being taken here. Then once you hit the button for check fraud, it is going to be created into a dictionary like this. This dictionary will become a data frame, and then it will all go through the same process that it has went through earlier. All the meta features, and then HTAG, CSR matrix is being created. Then you'll also get the predictions. I hope this deployment was also clear. And I sincerely hope that you were able to understand something regarding how a project is built, how a fraud detection project can be created. And I hope this gave you very good insights into the world of model building. Thanks for your time, and I hope to see you in the next one.